get started on your notes over another introduction to geometric proofs. We're going to talk about angles today. This is your day one lesson over angles. We're going to be talking about angles and angle relationships. I'm going to remind you of some helpful tips that you can use when you're solving geometric proofs. The first thing is what you're given will always be the first statement with given as your reason. What you are proving will be your last statement. You're going to write the justifications for each step in the reasons column, and you're going to refer to your reason bank for those reasons or those justifications. The reasons that we're going to be using today, or the justifications, are the definition of congruent angles. The definition of congruent angles tells us that if two angles are congruent, then their measures are equal. We're also going to be using the definition of a right angle, which just tells us that if an angle is a right angle, then its angle measure is 90 degrees. We're also going to be using the angle addition postulate, which tells us that if I have two angles that are right next to each other, I can add their angle measures together to get the measure of the entire angle. That's the angle addition postulate. And you might see that I skipped the definition of a straight angle, which tells us that a straight angle measures 180 degrees. That we're just actually not using that reason today. It's not in any example. But you will need to know it for future proofs. We're also going to be using the definition of an angle bisector, which tells us that if a ray bisects an angle, then the two angles that it creates are congruent to one another. We're also going to be using the definition of complementary angles, which tells us that if two angles are complementary, then they have a sum of 90 degrees. Or if they have a sum of 90 degrees, then they are complementary. The definition of supplementary angles tells us that two supplementary angles have a sum of 180 degrees. So let's get started on example number one. Example number one, we are given that angle EFH and angle GFH are supplementary. It also tells us that the measure of angle GFH is 55 degrees. So I'm actually going to write that down. I'm going to mark up my image. So that's all we know. And in geometry, we never assume anything, right? We have to prove everything. We are only given that these two angle measures are supplementary and the measure of angle GFH is 55 degrees. That's what we're given. So we write that in our first statement, everything that we're given. And again, you don't have to write everything that you're given in your first statement. You can write your givens throughout your proof, but we're given that. Okay, so a little tip, when you are given a vocabulary word, you need to define it. So we're given that these two angle measures are supplementary. What does that mean? Well, the definition of supplementary angles tells us that if I add those two angle measures together, I'll get a measure of 180 degrees. So that's your next statement. The measure of angle EFH plus the measure of angle GFH equals 180 degrees. And we know that by the definition of supplementary angles. So here's a little tip over here. When given a vocabulary term, define it. You must define supplementary angles here. Okay, so I like that these two column proofs are pre-filled so we can, we have clues throughout the proof. So in step number 3, what does it look like we've done here already? The measure of angle EFH plus what happened here? 55 degrees. What did I do? I replaced the measure of angle GFH with 55 degrees in my next statement. And I can do that by the substitution property of equality. So because I was already given, because it's already been stated in my proof somewhere that the measure of angle GFH is 55 degrees, I can replace it here. And again, we're trying to prove this. This should be our last statement. How do we get there? Well, I can subtract 55 from both sides, and I get that the measure of angle EFH equals 125 degrees, and I got there by the subtraction property of equality. Let's move on to example number 2. If you need to pause the video, rewind it, please do so. I get it. I'm going to try to go pretty quickly through examples 2 through 4. Example number 2. We're given that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We're also given that the measure of angle 1 is 120 degrees. Okay, so the total is 180 degrees. Measure of angle 1 is 120 degrees. I'm going to write those statements down. What's my reason? Given. It's always your first reason, what you're given. That's our starting point. So where can we go from here? We're starting here and we need to get to here. We are trying to prove that this other angle measure is 60 degrees. And you might look at this and go, yeah, I've been doing that for like 5 years. I know to do 180 degrees minus 120 degrees to get 60 degrees. Well, in this proof, we need to logically explain why we can do that. We're given this equation right here. We're given this angle measure right here. What can I do? I can replace right there in my equation 120 degrees. So I can replace the measure of angle 1 with 120 degrees because it's been stated in my proof already. And I did that by the substitution property of equality. So I replaced the measure of angle 1 with 120 degrees. I've got my equation here. How do I get the measure of angle 2 all by itself, which is what we're trying to do? I subtract 120 degrees from both sides, and I get the measure of angle 2 equals 60 degrees. What did I do right there? I used the subtraction property of equality. Let's move on to example number 3. We're given ray AC bisects angle BAD. Okay, well that means that these two angles are congruent, right? We know that. Okay, we have to prove it, but we do know that, right? Ray AD bisects angle CAE. Okay, so we now know that all these angles are congruent, really, but we need to prove it in a logical fashion. So that's what we're given, and we need to prove, and I'm going to write this down here. We're trying to get to angle BAC is congruent to angle DAE. You can always write that. Go ahead and write that down, right? You know that's going to be the last step in your proof. Okay. What's the reason? The first reason is always given. Okay. Again, we're given a vocabulary word here. Bisects. Because we're given a vocabulary word, let's define it. The definition of an angle bisector tells us that, okay, if ray AC bisects that angle, then that means the measure of angle BAC is congruent to CAD, not the measure, just the angle, right? Measures are equal, angles are congruent. So angle BAC is congruent to angle CAD, and angle CAD is congruent to angle DAE. Okay, a lot of times when you see segments or angles are congruent, not always, but in your next step, it tells us that either the lengths or the measures are equal. Okay, so our next step, we can say if the angles are congruent, the measures are equal, right? Angles are congruent, the measures are equal. And we get there by the definition of congruent angles. Okay, now, and if you need to pause the video, please do so. And you can always, like definition of congruent angles, you can write definition of congruent angles. You can write shorthand, right? So in statement number 4, okay, follow me on this. And I'm going to shorten it up. If BAC equals CAD and CAD equals DAE, then doesn't BAC equal DAE? Sure, it does. The measure of angle BAC equals the measure of angle DAE because both of those are equal to the same thing. So I can write that using the transitive property of equality. Okay, if measures are equal, then their angles are congruent, right? So that's our very last step. And I'm actually going to erase it. Can I erase it here? I don't know where my eraser is. Eraser. Okay, I'm going to erase this. And our next step is that we can prove that now if their angle measures are equal, then the angles are congruent by the definition of congruent angles. All right, let's move on to our last and final example. There's a lot of steps here, so let's get started. We are given that ray CE bisects angle BCD. Okay, so I know these two angles are congruent. I mean, obviously I have to prove it. We're given a vocabulary term. We're probably going to have to define it. We're also given that the measure of angle BCE is 45 degrees. Okay, we're asked to prove that angle BCD is a right angle. Okay, all right, well, let's get started. In the very first statement, we're given that ray CE bisects angle BCD. Okay, our reason is given. This is an example where I'm not writing all the givens in my first statement. Okay, we're going to go through kind of a thought process that just involves the fact that ray CE bisects angle BCD. Okay, obviously we're given a vocabulary word. Let's define it. What does it tell us? Well, if ray CE bisects angle BCD, then these two angles are congruent to one another. And that is by the definition of an angle bisector. So BCE is congruent to angle ECD. Okay, what could be our next step? If the angles are congruent, tell me about their angle measures. Well, they're equal by the definition of congruent angles. So we're going to use the definition of congruent angles to show that congruent angles have equal angle measures. So there's kind of our little thought process involving the fact that ray CE bisects angle BCD. Okay, let's go another route. We're stating another given here, that the measure of angle BCE is 45 degrees. Okay, look at step number 5. I'm sorry, there's a clue there. Well, how did we get from 4 to 5? Well, we've already stated up here that these angle measures are equal. And now we know that the measure of angle BCE is 45 degrees. So, can I replace that angle measure in that equation shown in step number 3 with 45 degrees? I sure can, and I can use the transitive property of equality to do that. Some of you might want to say, well, why isn't it the substitution property? I got to be honest, as a teacher, I would totally accept that from students. However, if you are let's say you have like A plus B equals C, and then you have like A equals 4, well, that is when I would be using the substitution property, right? So here's the substitution property. But when you have like the entire thing, the entire like side of an equation, basically, or the whole expression, the whole thing, that's when you'll use the transitive property of equality. But I get it that it's totally difficult. And so if you struggle with that, then you're completely normal. Okay, so let's move on. The angle addition postulate. There's another clue over here. Okay, well, let's use that. Let's start there. The angle addition postulate, what will that tell us? That tells us that the measure of angle BCE plus the measure of angle ECD equals the measure of the entire thing. Okay, well, where do we go from there? We know we're trying to get to the fact that angle BCD is a right angle. That's what we're trying to prove. Okay, where can we go from there? Well, we know that the measure of angle BCE is 45 degrees, and we know that the measure of angle ECD is 45 degrees. So can I replace those two values in my equation? I sure can, and that would be an example of the substitution property of equality, because I'm replacing this piece and this piece. Okay, so now my next step says I'm going to simplify. How can I do that? Well, 45 degrees plus 45 degrees is 90 degrees. So the measure of the entire angle is 90 degrees, and we've shown that. We've proven it. Let's erase this. Whoops, I've already clicked it. We can then say that if the entire angle is 90 degrees, then angle BCD, the entire angle, is a right angle by the definition of a right angle. That concludes your day one notes over geometric proofs involving angles. I hope it was helpful.